Welcome to episode 6, and today we're going to do something new. We're going to do something, well, I've decided to do something called a render engine. Yeah, I've decided to go for the complete kit and caboodle. We're going to do draw entity, draw terrain, and a master renderer. It's the master renderer that the user will use. They will add the models in through the master renderer to be drawn. The master renderer will then take those models and then use draw entity or draw terrain to get them on the screen. Simple. This means that we will be able to have different effects for the terrain and different effects for the entity. We'll also be able to add extra draw routines later on, like draw water, draw clouds, that kind of thing. We'll be able to add those later on and then just attach them to the master renderer that will do everything else for us. Isn't that awesome? So it's fully expandable. That's what I'm trying to get at. I'm doing it in a way that we can expand it at our leisure. Isn't that nice? So, without further ado, let's get this started. Source. In the source folder of Amber SL, we're going to have a new folder. Call it Render Engine. Lovely. There we go. One Render Engine. In Render Engine, for today's video, we will be doing 2 files as usual. So it's a new file. The first one being draw entity. This is how we're going to start things with the .h, and here we go. Let's change color. Good. New file, draw entity, and that's going to be the CPP file. There we go. And we'll do things as normal, hopefully. Whatever normality is around here. Hash include, and this is in CPP file, and that just includes the draw entity.h file. Nothing surprising there. There we go. And yeah, I'm happy with that setup there. Let's get this bigger now. Now we're into it. It's going to be hash paragma once, as we always do. Then we're going to get the includes. This is where the fun starts. I've got a list of includes to get through here. So, C++ includes, what shall we have? Well, the first include we're going to have is OpenGL. So we'll start with that one. So hash include, and that's going to be GL slash glue, isn't it, we're using for OpenGL. There we go. What else do we need? We're going to need something you don't know about, probably, or you may never have used. I'm going to use something called map. Ooh, Mayo map. There we go. That's an actual thing for C++. And we have used in the past vectors. So we may need those. We'll pop those in anyway. Vector, yep, we'll have that. Now, from what we've written, we're going to use quite a bit, I think. What do we have in maths? Oh, we have maths.h, that's okay. Let's include that. So that will be ... up one across to maths, and in for maths.h. That's lovely. What else shall we have? Good question. How about some entities? Yes, it's going to be dealing with entities. That's a good idea. So what do we have in entities? Let's have a look. Oh, camera. Yeah. Let's have a camera. Camera sounds good. Yeah, so it's entities. And that's just going to be camera, isn't it? Yeah. So we'll have one of them. Definitely, we'll need one of them. I like the idea of that one. Let's see what other entities we might need. Well, entity itself, because this is the draw entity. That might help. Entities. Yeah, just entity, isn't it? There we go. Entity.h. Yeah, we'll have that one. Do we need any more? Camera, entity. Nah. That'll do for now. If we need any more, we'll just add them to the list after. Hash include. What else do we need? I'm going to need a shader because we're going to draw it. So that comes under OpenGL. And we're going to use static shader, I think, for this one. So up one, across to OpenGL. And then can I have a static shader, is it called? Yeah. There we go. A static shader. .h. Anything else I can think of? No, not really. I have a feeling we might need some others, so we'll come back to that. We'll come back to it. It's as simple as that. There's no point in going wild at the beginning and thinking we're going to need everything and then finding out we're taking includes out. That's usually a bad way of doing things because we always forget to take things out. It's easy to put add to a program. It's hard to take things out. Funny, but true. So let's go down to here. Set up some namespaces, I suppose. Yay! So let's have Amber, our usual one. Namespace. This is OpenGL. Nope. This is a render engine. Woohoo! That'll be a good one. Render engine. There we go. For this namespace, we are going to have a class, and it's called draw entity. So capital D now. Draw entity. That's right. Not. I put one extra I in there. There we go. That's better. And we'll open that class up and put a semicolon at the end because it's C++. Semicolons all around. This is where the fun starts. We need, what they called? Oh yes, variables, them things. Yeah. And we need coffee. Of course we need coffee. Oh, that's lovely. So, we're going to need a matrix. We're going to need a matrix for, let's call it projection matrix. There you go. That's a nice long one. Projection matrix, we'll have one of those. That's going to deal with the aspect ratio of the screen. It's also going to deal with how far the furthest draw distance is and how near the closest draw distance is. So that's going to deal with a few things. Oh, and the angle of vision, I believe, is in there as well. So that's going to be quite a nice matrix when it's all said and done. We'll need something from the shaders. So it's going to be OpenGL, isn't it? Yep. Static shader, maybe. Yeah, we'll have one of those. We'll just need a pointer, an address to the static shader wherever it's been placed. So we'll call that shader. Yeah, we can do that. Lovely. OpenGL's now got squigglies. Thank you. No, it hasn't. Camera. camera is in entities, isn't it? Yep. Camera. We'll have view. Again, it's just a pointer at this stage. We don't need the actual camera, we just need to know where it's located in memory. So at this stage we are onto pointers, which is fine. We won't be copying the camera into here, we won't be copying the shader into here, we just want to know where they are instead. Easy to work with, that's why I like C++. You can define which way you want to work, which is great. Now, if I remember rightly, we currently only have 3 attributes. We had attributes 0, 1, and 2. So I'm gonna actually keep that. It's an unsigned int. Yeah, and I'm just going to call it num attributes, I think. That's just going to allow me to set up some for loops, to be quite honest with you, I think. Yeah, that's what I'm going to use that for. It's obvious what I'm going to use the shader for and the camera for. The shader is the output and the camera is an input for where the camera is, basically. Yeah, does help to know where it is. For now, that'll do. I don't know if we're going to need anything else. I wouldn't think so. It's not a complex thing that we're putting together here, but it looks complicated because I've added a map. Now, let's talk about map. Map is a function library of C++ where it takes a key and then it takes a value. And it will, if you have the key as, say, blue, and then the values, say, sky, water, air tint, whatever you want. You know, you can, clothing, anything could be blue, shoes, socks, you know. It would then list all of those detail, it would then list all those against the key blue. And we are going to use the key of, well, for now, we're going to use a key of textures because I've decided on textures mainly as we only have a single texture for each model, but we might be using each model more than once. Does that make sense? We can reuse a model, but instead of reloading the model into the system, and then reloading the texture into the system, what I'm going to do is register the texture as a key and then just list the model which is coming from the same place. It's just a copy of the model that we've loaded. We only have to load it once and then we just make copies of it. Simple as, and that will save a lot of time and energy, especially when you come to drawing them. If you were to load each model individually and you loaded 1,000 models, you would have to draw 1,000 models. What we're going to do is load one model and then just draw it 1,000 times. Doesn't that sound better? Economically, it's 1,000 times faster. Yeah. And when we come down to doing like particles and visual effects like fire, for instance, you will find there are a lot of particles involved in that, and you will be drawing 1,000 particles for a fire. So you would then use as a key fire, and then you would put 1,000 particles, and you could then draw them all at once. That sounds better to me than trying to do each individual particle and keep track of it individually and draw it on the screen. That ain't gonna work. That's way too much processing power. So this is my idea for the render engine. It's going to be a batch renderer. It's going to render things in batches. So a single batch will be an individual model, maybe. Haven't quite decided. We'll get there in a second, I suppose. And all we do then is add things to the batch, or the user will add models to the batch system. the batch system will register it, and then when we call the draw, the render engine's master renderer draw, it will then take all of those batches and put them out to the correct draw routine, in this case draw entity or draw terrain. Interesting. Will it work? Well, yes, it will. I know, I've just spent 2 days testing it. So yeah, it did take me a couple of days to get the master renderer to work and use batch rendering and use it properly, so I'm quite happy with the result. This is the constructor. Yeah, and I'm coughing a little bit too much here, so just 1 second, let me clear. Okay, a bit less coughing now. So I'm going to ask the compiler, or tell the compiler, that we want to be explicit about this, that the user will have to set it up using these variables. They are not going to be able to just set it up as a blank constructor. So I'm going to be explicit. I'm going to take draw entity. There we go. And we're going to open the brackets, of course, and we are going to take in the shader. And where did we leave our shader? In OpenGL, didn't we? And that's just static shader now. And we're just going to take in a shader. Like that. So whatever shader is passed to us, hopefully the static shader is passed to us. I haven't put any error checks in for that. Just thought of it. I'm not going to worry about it. Error checking is for people who don't program properly, and I'm not sure if this is fully programmed properly at this stage. I believe there should be error checking still. This is not a final version, which you've got final versions of the code previously, which has been fully checked and error checked. But I'm confident that this is going to be as close to the final code as we're going to get without modifying the code completely. So I'm going to use a title, not a minus sign, a title. That's squiggly one that goes up and down a little bit. And we'll just do the destructor as well. Normally I don't put them in, but we've been explicit. So I'm going to be putting that in just to let the compiler know that, you know, you can destroy this okay. It's not going to have any funny business. Plus we might also put something in there, you never know. Now, what kind of things do I want? I want to be able to prepare ourselves to do the drawing itself. So I always have, my drawing routines are always prepare, render, and then finish off. So those are the 3 stages. So I want to prepare and render which the user can use. The finish off I'll probably do for them. I usually do, because it depends on what they've put in for the prepare and render, what we have to unbind and things like that. So the first one is going to be void prepare, and all we want to do for our preparations is find out what value that projection is. Now, why have I just done that? Why have I not put a star in front of it? I'm copying the projection over. It's a matrix. It's not an expensive idea, and it's only going to take the address off that. Bit of inconsistency going on, you see. I'm spotting the inconsistencies in what I'm trying to do. And it is a map 4. It's a matrix 4. Okay, I'll leave it as that. And we'll have a render. Void render, and this is going to be a bit more difficult. This is where the mapping comes in, because we're going to have to take in from the master renderer the full prepared map of keys and objects associated to those keys so that we can render them all. So we're going to have, it's from the standard library, it's called map, M-A-P, and it isn't a function. It's an input iterator. So it's an actual iterator we need next. That's an angle bracket for an iterator, if you want to know. That's how C++ does its iterators. An iterator is a pointer that iterates along an array. So it points to which slot we are in the array. So our iterator for this is going to be amber. Our iterator is going to be the texture, isn't it? So we are going to need textured model. Okay, we haven't got it. Let's have it. See what I mean? Hash include. It's .. backslash, and it's going to come under models. That one there I want. I'm glad I was talking through that. I would have got that wrong, but no. And then it's a model. And we're having it textured. Yeah. And it's just a .h. Hello, Muppet. Thank you for banging the stand. That's the cat leaping up on me. Okay, that's lovely. Thank you, cat, for standing in front of this screen. Models, model textured. Yes. So that's what I want in here. Come on. Come on. Come on. Come on, Muppet. Thank you. So our map is going to be... it's just going to be... yeah, models, isn't it? Models, colon, model textured. Thank you. Come on, cat, out the way now, please. Thank you. Oh, okay. So that's the key. That's the key that we're going to use, the texture. Next part of the map will be the item. So type name key, type name type for whatever the object is that you are keying to, which is a vector. So it's an std. Yeah, this is complicated stuff. I mean, this is harsh, complicated stuff. This is really going deep into C++. I'd say advanced, maybe. A vector needs an iterator, which is going to be entities, which we do have. Yeah. So that's entities, colon, entity. We do have that. And that's going to be a pointer, please. So I'll have a star. That's an iterator. We are then going to end the map iterator. So another one of those. And this is going to give us, or we're going to call this entities. That's our name for it. But all I'm going to do is ask it for the address. I don't want to copy the whole map into our render engine. All I want to do is copy the address of that map in the render engine. And so I'm just going to ask for the address. I don't want the whole damn thing. It'll take ages to copy a full map across. We're talking, you know, like stuttering graphics ages. That's not a good idea. So I'll just use the address. So it's going to pass a single address over that will point to all of this lot. Isn't that nice? What else are we going to ask for? Oh, let's ask for something else, shall we? going to need the map, which we've now got. We better have the camera as well. We haven't got the camera yet. So that's in entities as well. I've only put it on separate lines because it's easy for me to read. You don't have to. Camera, yeah, we've got camera. Start camera. We don't. We'll just take the a pointer for that, or an address, basically. It's a different way of getting an address, but we're just going to create a pointer for it, a new one. There we go. That's that done. Have we got our shader? No, we haven't at this point. Where's our shader? Our shader must be somewhere. Oh yes, we have. We've got our shader here. Yep, that's done. We've got our camera. That's done. We know how many attributes. That's done. That ties in with the shader. We've got our projection matrix coming in through here. Yeah, that's fine. I'm still dodging about on that one. I'll find out when. The problem with this is I don't know yet because we haven't written the code. There we go. And the answer is, well, we haven't here, so I haven't here. It's matching. It has to match, so if I change this, I have to change this. Does that cause problems? Nah, not really. Just means I have to be careful on how I use it. That's all it means. Render, I'm happy now. We've got everything. So we have everything that we publicly need to transfer across. We've got all the information which we need from the user. We will need some extra bits and pieces. We will need private functions to help us do all of this. We're not just going to magically do it all. So, yeah, preparing. What do we need to prepare? We need to prepare the instance for whichever instance we are. A single model we call an instance. So we are going to prepare an instance. That means preparing a single model for drawing. Instance. There we go. That's better. There we are. And for that, we're just going to need the entities, aren't we? There we go. Colon, entity. And it's just entity. Let's put that extra I in for some reason. I don't know if that's a Freudian slip or not. An entity. I wonder. We're also going to have to prepare the texture. So we will do that. Prepare, but we've passed in it as, well, we've passed the texture in as a textured model. So let's call this prepare the textured model, or what would you pass it in as? Yeah, I'm just going to call it textured model now. Makes more sense at this point to call it that. And don't need anything for that. Make sure. Yeah, it's part of the renderer, so it's actually inside here. It's inside all of this lot, so no, we don't need anything for that. It's wrapped inside something else. Lovely. And the last thing that we'll need is, as I said, there's three parts to this. There's a prepare, there's a render, and then there's an undo. Well, the undo part we call unbind. So we'll have an unbind. And that will come up as textured model. Because the texture is hidden in there again. But for this, we need nothing. We do need a textured model, don't we, for that? How's it going to work it out otherwise? Yeah, I'm going to put it in. I'm going to put it in. Textured model. There we go. So it's models, text, model textured, sorry. Just call it model for now. Is it an address or not? Is it automatically an address or not? Is it starred here? No, it's not. It's just a type. And I'm going to type copy. Yeah, okay. I don't think that's a problem because it's a single one rather than multiple ones, as in this case. That's all of the entities we are going to render, where this is just preparing one. So preparing instance is preparing one, preparing the texture for that instance. And then of course we have to unbind the texture once we've finished with it. And we're finished with it after all the models using that texture have been drawn. Yeah, so that's why it's here in the private section, not public. We don't want the user to mess that up for us, so we'll do it ourselves. How about that? The user doesn't have to worry about it then. Do I need anything else? Probably. No. No. Is this supposed to be a pointer? Keep thinking no, it doesn't. Every time I read that, I'm just saying no, it doesn't. So, no, it doesn't. Finish that. Yeah, I'm happy with that line now. There we go, that's it. So here, how we go into draw entity, and it's going to be a namespace. Hold on a minute, let me just check the time here. 31. Yeah, set it up because there's going to be a lot to do. Namespace, Amber. Here we go. And namespace. Which one are we on now? We're on a render engine. There we go. Lovely. Isn't it looking nice? I think it's looking quite good. This is definitely looking quite good. So what we do is we take from the public bit all the way through to the private bits. There. Copy them. Paste them. And let's set them all up. So I don't need explicit anymore. Thank you. I do need draw entity because we're going to make everything a member of draw entity. To make them a member, we just put the name and 2 colons. Oops, too far on that one. And 2 colons. That goes there. Let's bring these 2 back. That didn't work. And that's void prepare. Put the draw entity in front of that one. And draw entity in front of that one. That's looking good. That's looking very good. To stop me messing around with these, drag and delete. Control V, colon. Yeah, I mean, it's silly, I know, but we have to do it. It's all about the namespace and keeping things separate, making things members of a class. Very important structure, which allows us to do all this fancy stuff and not get all our variables cross-matching and messing up. Nice, let's just check everything. Yeah, I'm happy. So that's that really done. Do we need anything special on our draw entity up at the top? I doubt it. I doubt it. Yeah, we're just going to do a standard constructor. I thought so. So it's a colon. I always do we can continue on the same line. It's up to you. But I always drop to a separate line. So m_projection matrix. is going to be our mat4 colon, and that is going to be, we haven't got one. We haven't got one. Or have we? Do we? I've got all the R zeros and stuff. We don't have one. Okay, well, I was going to set it to 0. To set a matrix to 0, it's the 0th matrix, or empty matrix, should I say, is called an identity. That's actually what it's called. It's called an identity matrix. That is a matrix that holds nothing. We don't have it. So we will have to do that. There we go, identity to maths map4. Add identity to maths map4. There's going to be a lot of this, by the way, because we didn't complete the maths, we just set them up. So now I am finding out what I need to do. Over in map4, that's this one here. Functions belonging to map4. Identity. So that needs to belong to map4. That's the identity matrix. Okay, that's set up now. Thank you, map4. That'll remind me to do it. It's not a problem. So I'll just say that out a second. What else do we need here? That's a projection matrix. I just need the shader down to m_shader. Yeah, that's right, shader. Sorry, I'm double guessing myself there. Open brackets, and it's just shader. There we go. That's lovely. That's lovely. Can we bring you back? Yes, we can. Lovely. Let's just check our header file, make sure our header, yeah, it's working all right. That's it. It's done it. Lovely. So that's a standard setup with something we haven't written yet. Yeah, I told you this had happened, that we will have to go back and actually write stuff and add to maths. I said that during the maths bit back in stage 2, I think it was, when we did maths. I said this is just the setup and we will have to add to it when we know what we need to add. Simple as. That, I don't think I'm going to do anything in here. I'll tell you what we're putting in here straight away. It's an obvious one. It doesn't do anything, the constructor, it just constructs the draw entity. That's all it does, and allows us to access then the prepare and render. So that sets up everything else. So that's empty, because we won't have anything to destroy by the time we're finished with this. Draw entity is a function. Sorry, prepare entity is a function. What am I talking about? What are you talking about, Blades? Get your head together. That's going to be easy. Because all we're doing is taking in the projection. So m_projection matrix equals projection. That's it. That's the whole thing. Yeah, okay. Then we get the complex one. What we're going to put in here, I think that's next episode. Yeah, I think it is, because we are going to need to write all of these as well, because these all go into this draw, this render. So all of these have to be done now. Oh yeah, private. What do I always do with private? I highlight it and swap it to that to remind me that those are private and not in the main class. Sorry, available to the outside user. Not available to the outside user. This is our working out, our scribble pad for draw entity. There we go. Just do that. That's okay. Doesn't do anything yet. None of them return anything. This is fully just doing functionality of taking in all of the variables that we've been setting up when we're loading stuff and sending it through to the shader and onwards to your graphics card, through all of that shader programming. So you can see now how much programming our data is going to go through just to get to the screen. And at the moment we've been very good. We kept it all nice, short and clean. So we're going to have a very, very good result, and I can guarantee you're going to be amazed at the results, because this style of drawing is darn fast, I'm going to call it, because there is very little code involved. When all of this gets converted into machine code by the when we build it into machine code to run it, or to access it via the, via the static library, we're going to be accessing beautifully small, compact, concise code, and it's going to be very fast, and that's a guarantee, absolute guarantee, because of the way we're doing it. The slowest part is going to be the map, and even that will be simplified out after it's been built. In the building stage, it will simplify all of this out into machine code, which is nice. It's beautiful, and that's another reason why I program in C++. That's all done for us. We don't need to worry. As long as we do the programming right, it will compile and it will streamline it for us, because we've made it easy for the compiler to do that. And that was why I spent 2 days writing this, to make sure that I did it in such a way that we were compiling it into a streamlined, beautiful piece of... I actually looked at it as well, and it's quite funny. I looked at the machine code for it, and my God, it looked good. Not very many procedure calls in there, which are the bane of C++, and people writing in C++ is when it goes through to the machine code, the compiler has to use a lot of function calls. Well, this compiles down to less function calls than you would believe, and less code than you would believe. I'm just looking through now for anything that's going to be a problem. Prepare instance is going to be a massive problem. That's going to be all the calculation stuff. So prepare instance is going to be our calculations. What's prepare texture model? That's simple. And unbind texture model. Simple stuff. Yeah. Right, I'm happy. Yeah, I'm happy that this is going to work right. Yeah. Yeah, it does, because we've got the OpenGL parts in there. Yeah. Okay. What I'm going to do then is I'm going to prepare myself to do episode... what are we up to now? 6, 7? Well, next episode will be episode 7. And in that, we'll do the main render function, and of course all these helper functions, which will be to help the render do what it needs to do. So probably do bottom up. I think it's going to be another one of these where we do bottom up. That's a good idea. Let's do that. So I'll catch you in the next episode with a bottom up, and we'll get this finished and onto the terrain entity. Draw terrain. Yeah, that'd be good. It's basically the same thing, but with draw terrain added to it. There's a few differences though, because the texturing is different, I suppose. I'm not sure. We'll see. We'll go there and find out. How's about that? Let's journey onwards. So I will catch you in the next episode. So in the meantime, take care and have fun.